All right, Algebra 2, here we go, guys. So welcome back. We're in Section 8 today. All right, Chapter 2, Section 8, 2.8. Everybody have your textbooks open to page 150. All right, so we are jumping into absolute value equations and inequalities. All right, so we're going to be doing some graphing on number lines. There's some key things to remember with inequalities that we have already covered. One of the first things to remember is when you multiply or divide by a negative coefficient, what does that do to the inequality sign? It flips it, okay? And then we're going to be adding a little bit of an extra thing when we deal with absolute values. So pay close attention to the example problems when I'm going through absolute values, and you guys should be fine. If you're not watching these videos, for starters, you wouldn't even hear this little thing that I'm saying right now, but you need to be watching these videos, all right? I'm hearing stories of students potentially struggling a little bit, so watch these videos, okay? Ask questions, keep the effort high, all right? You guys can do this, but it takes the effort on your part, and ask me questions, all right? Let's jump into it. So for starters, we have three key terms. You got to find the key terms. You got to define the key terms. Why? Because it's like I say every time. If you don't know these definitions when the words are used by either me or the textbook or the test, and you don't know what they mean, there's no help coming your way. So put in the time now, all right? The next thing, there are three charts. You got to find all three charts. There's two of them on page 151. Copy those down. There's one chart on page 152. Copy that one down, all right? Take the time to do that. Let's move in. Here we go. Okay. Compound inequalities. That basically means you're going to have two inequalities being put together, or you could actually see two separate inequalities, but they are essentially being graphed all together, okay? And absolute value equations, they're going to express the same thing. You're going to have two parts, meaning two answers, meaning two different parts graphed on the same number line. Okay, so when they say graph, you're graphing it on a number line. All right, two parts, two answers, two individual parts, but they are on the same number line. All right, so follow with me through the examples. Then you're going to see these two symbols here. One looks like a U. You will be using that with the word or, and that basically means it includes both parts. So this U, imagine it like a cup. You could fill it up. It will fill with water. It will hold the water. So it's going to include everything. Then you have this upside down U. That's going to go with the word and that means only where they overlap. Okay, so you could kind of imagine you can't really fill up a cup that's already upside down. It's only going to have a couple drops of water there at the top. That's all that's going to be left in it. So the upside down U is the only parts where graphs overlap. All right, you're going to see me do an example problem with that as well. So let's jump into those examples. Here we go. Okay, so the first one we have here, I've kind of started to tell you the important parts. I circled the word or. That's very important. So the note off to the sides means you are graphing both parts no matter what. Okay, and you'll understand what I mean by no matter what here very soon. So the first step, you have two parts. Let's get the two answers to those two parts. Okay. All right, so the first inequality here, we have to add 2 to both sides, giving us x less than 3. We got that word or. Then on the other side, divide by 5, and you have x greater than or equal to 6. Okay, so the first parts we've taken care of. We solved both inequalities, and we have two answers. Now you have to graph these inequalities. All right, so we have x is less than 3. Make sure you notice you're going to have a number line with arrows on both ends, and you always have to represent 0. Why do you always have to represent 0? Because that tells me the positive and the negative sides. If I don't know where 0 is, then I don't know where the positive side is or the negative side. So you always have to represent 0. All right, let's go 1, 2, 3. So there's the number 3. Now, how do you graph inequalities on the number line? Don't forget, this is going to be a less than, and it does not say or equal to. So that means we have an open circle. All right, open circles are just for the less than or the greater than. They don't have or equal to, so they are open. And this is going less than, so it's going to the left. Then we have positive 6, so let's go 4, 5, 6. Now this has the or equal to, so we're going to go a circle, and then we're going to fill in that circle. If it does have the or equal to, then that means you have to fill in the circle. And this says greater than. So we're going to the right, greater than. That's the full answer here. You have 2 parts, 2 answers, 2 graphs on the same number line. All right, next one. Here we go. Okay, notice we have the word and. Now, one piece that I did leave out here, just so you guys know, this would have the U shape. So I'm going to put that right there by the or, just so you know. There is the U shape that goes with it. All right, now we move into example problem 2. This has the word and. So remember that this is going to give us the upside down U shape. Okay, so first step, solve both parts. Divide by -3. Divide by -3. Remember, when you divide or multiply by a negative coefficient, what does that do to the inequality sign? It flips it. So now our inequality is flipped. These guys cross out. There's the x, giving us a positive 4. All right, now the other side. Subtract 4, subtract 4, x less than or equal to 8. All right, so we have the word and, we have the upside down U. So all of that is telling you, you are only going in your final graph to show me where the 2 parts overlap. That's what the word and means. All right, so let's see what that would look like. You have the 0, you have the number line. So let's go 1, 2, 3, 4. And 5, 6, 7, 8. So these are the 2 numbers that we care about here. The 4 says greater than, and it's open. Remember, it's open because it does not have or equal to. And so it says greater than. So we're going to go to the right. All right, now the 8 right here. But this does have the or equal to. So I have to fill in the graph, and this says less than. All right, so now what you are going to do is you are going to bold the line in between the 2, because that's the only part you want to show, because the word and means only truly graph where these parts overlap. If this part goes to the right, this part goes to the left, you're going to see they will overlap in between each other, but you don't include any other parts. So you bold where they overlap and leave the rest blank. Okay, and don't forget, circle up these guys. Those were the solutions there. Okay, let's move into the third example. Now we're getting into absolute values. You'll notice there's an equal sign. If there's an equal sign, you are not going to need to graph, but you will need to solve. Okay, if you get the inequality, then you will have to graph. All right, what do we do for absolute values? Well, there's 2 parts, seemingly 2 parts for all problems in this section. Okay, the first thing you do is rewrite it just the way it was given, except we're taking out the absolute values. Okay, so just rewrite it, but take out the absolute value sign. We're going to solve that. And let's subtract 9, All right, subtract 9. X equals 4. All right. Now, how do we get the second solution? What do we have to do here? Well, the first part, the x plus 9 stays. We don't change that. The equal sign, it stays. We don't change that. But the piece we do change is the constant that is by itself. That's the 13. We now make it negative 13. Why do we do that? Because absolute values must represent both parts. Remember, if I had negative 13, but what's the absolute value of negative 13? It's positive 13. So I have to show both parts, both the positive 13 and the negative 13. Because if I plug both of those in, the absolute value for both is still positive 13. That's why. So subtract 9, x equals a negative 22. And that's it. Those are your two solutions. Okay? So for the absolute values, don't forget, you must always change the constant value that's by itself to represent both the positive and the negative side. All right, let's do the next example problem. We will be solving and graphing here. Okay, so what does it look like with an inequality? Well, the first part, don't change anything, just take out the absolute values. That's the easy part. 4x minus 8 greater than 12. We're going to solve that. But what does the other half look like? Now, there's one extra step when there's an absolute value and an inequality. So the 4x minus 8 doesn't change. You'll notice that stays consistent. That's the same. But here's the extra second step. You have to flip the inequality, and you have to still change and do the opposite of whatever that original value was. It originally was a positive 12. Now I have to make it a negative 12. All right, let's go through our steps to solve. Add 8, 4x greater than 20, x greater than 5. So that's part of it. That's the first half of my solution. Let's do the other side here. Add 8, 4x less than, let's see, what's that going to be? A negative 4. And divide both sides by 4 and get a negative 1. Okay, there's our solution there. But we have to graph it. Okay, so let's try to fit in a number line here. Right there. There's our 0. And let's change the color. Here we go. So we have 1, 2, 3, 4, 5. And then we have a negative 1 on that side. Okay, let's see what this would look like, because we don't know if it's an and or an or yet, do we? So let's graph it. We have x right there is greater than, and then with the negative 1, we have x is less than. You'll notice these guys are going in opposite directions. Now, when they're going in opposite directions of one another, then you will be representing an or. An or. So the word or needs to be in between these two. All right? If they go away from each other, in other words, there will be no overlapping, you will use the word or. If they go towards each other, you will have overlapping. You're going to use the word and. So you'll notice they didn't give us any words at the beginning, meaning you have to graph it to figure out what the word will be. Use the word or, use the word and. All right, let's do the next example. Okay, now there's one step here that we haven't shown yet. You have to get rid of this first before you can do anything in this problem. So we have to get rid of that 36 by subtracting 36 on both sides. All right. So let's subtract 36 on both sides. So the 3x will still be there. The inequality will still be there. And we get a negative 24. Now you can proceed just like we did in the last problem. Okay, so we're going to need to rewrite this. Let's get one of them over here, one of them over here. So you have, just like it was given, 3x greater than negative 24. Then this side is 3x. Flip the inequality because of the absolute value and change this to be whatever the opposite is. They gave it to us as a negative 24, so now you're going to make it a positive. All right, go through your steps of solving. Divide by 3, divide by 3. X is greater than a negative 8. Same thing here, divide by 3, divide by 3. X is less, or sorry, yeah, X is less than positive 8. All right, let's fit our number line in. Okay. All right, 1, 2, 3, 4, 5, 6, 7, 8. Same thing here, 1, 2, 3, 4, 5, 6, 7, 8, negative 8. All right, we have x is greater than negative 8. So we're here going to the right. X is less than, we're here going to the left. Notice these guys are going towards each other. So we will bold in the whole thing in between. And what is the word that goes in between them if they go towards each other? The word and. So we will have the word and. We have a solution here. We know it's the word and. We have a solution here. And we have our graph. Okay. Stay with me, guys. I know we're getting into a longer video here, but stay with me. Okay. Now, in the last problem, we had one step we had to take before we could fully proceed. Same thing here. You got this guy that needs to be multiplied right there by the 4. You got to get rid of whatever is not in the absolute value. Do that first. Get rid of that first. So how do you do that? Multiply by 2. So you're going to now have absolute value x minus 5 is less than or equal to 8. Okay, so that's the first thing. Rewrite that. X minus 5 less than equal to 8. Now, x minus 5. Flip the inequality and do the opposite of positive 8. So greater than or equal to negative 8. All right. Let's solve. Add 5. Add 5. X is less than or equal to 13. Add 5. Add 5. X is greater than or equal to negative 3. Okay, so we have our solutions that we're solving for. Now we need to graph it on a number line. All right, and let's just save some time. Let's say that all the way over here, yep, that's 13. And right here, that's negative 3, just to save some time for us. And x is less than or equal to, so we have to fill in that circle. All right, and it's less than, and over here, x is greater than or equal to. So again, we're filling in this. And because they go towards each other, what's the word that we're using? The word is and. And we are filling in between. All right. Last example problem here, guys. Stay with me. We are almost done. Pay close attention. This last one's going to go real quick. All right. Pay close attention. Remember, anything not in the absolute value, you have to get rid of first. So how do I get rid of that negative 2? I'm going to divide both sides by negative 2 to get rid of that. So that's going to give us absolute value x plus 5 greater than negative 5. Here's the concept. Pay close attention. Think about this. Anything in an absolute value comes out of the absolute value as a what? As a positive. So again, anything inside the absolute value comes out as a positive. So I'm just going to write this word positive because anything in that comes out as a positive. Greater than negative 5. Now think about this. There's one step, one little thing that I forgot to do right here, didn't I? This guy should have been changed because I divided, right? I divided by a negative 2. I should have flipped that. So there's one little thing that I needed to do. That should have been like that. Okay, back to the concept. Anything in that absolute value is going to come out as a positive. Now let's think about this. Will a positive ever be less than a negative? I'm talking about this right here. Will a positive ever be less than a negative? No, it will not. Therefore, right off the bat, this one has no solution. Okay, so that was all conceptual. You didn't really have to do much math there to figure out what we were trying to get at. First step, get rid of anything that's not in the absolute value. We did that by dividing both sides by negative 2. Then, Mr. I almost forgot there, you got to flip the inequality. Whenever you multiply or divide by a negative, after we flip that inequality, we then ask ourselves, is a positive ever less than a negative? No. So that's why we get a no solution as our final answer here. All right, guys. Whew. Okay. I'm done. All right. I'm sure you guys are more than done. All right. So take the time, put in the effort, ask questions if you got them, and you guys are going to be just fine. All right. I will see you in the next video.